This video is about geometric series and how to build a general rule for a geometric series. So let's start with an example. The example is 2, 8, 32, 128. So the first obvious question is this a geometric sequence? So we can look at that and see that to get from 2 to 8, we multiply by 4. From 8 to 32, we multiply by 4, and then we multiply by 4 again. So it seems like we are multiplying by 4 over and over and over again. So yes, this is a geometric sequence. But what if we're asked to find the sum of the first n terms of that sequence? In other words, we need to find a formula for this geometric series. In order to do that, first we need to find a formula to find the nth term of the sequence. So we know we can make the table. The first term is 2, second term 8, third term 32, fourth term 128. But what if we wanted to find the 100th term? We've done this before, but we do 2, and then to get to 8, we do 2 times 4, 2 times 4 times 4, 2 times 4 times 4 times 4. And so we know for 100, the 100th term is going to be 2 times 4 over and over and over again. A bunch of 4s, but how many 4s? Well, we can look at the pattern and see that there are going to be 99 4s there. Slow it down if I went too fast for you. Go ahead, check it out, make sure you understand it. This is review, we've done it before, but if it's still kind of new to you, pause the video, look it over, work it out, see where all those numbers are coming from. How does this help us get our rule? Well, we can plug in n instead of 100. We still have 2 followed by a bunch of 4s. We're still multiplying. And how many 4s are there this time? Well, it's 1 less than the term number. So it's n minus 1. So our direct rule is a sub n equals 2 times 4 to the n minus 1 power. Again, if we went too quickly there, pause, go back, rewatch, do what you need to do to understand where that direct rule came from. Alright, so for this is the sequence. I just put in there that nth term, so we have 2, 8, 32, 128, and then the nth term is 2 times 4 to the n minus 1 power. If we wanted to sum the first n terms, we would just add them up. So S sub n for sum is equal to 2 plus 8 plus 32 plus 128 plus a whole bunch of stuff plus 2 times 4 to the n minus 1 power, because we're just adding together all of the terms. So how can we find out what the answer to that is? So in order to find the answer to that, you would just, there's a little trick you can do. We can multiply by 4. And when we do that, well, we get this. How did we get that? Well, 2 times 4 is 8. 8 times 4 is 32. 32 times 4 is 128. So if we're multiplying 4 by that sum, the distributive property just tells us to multiply 4 by all of that stuff. So 128 times 4 is 512. Something times 4 is going to get us that. And then if we multiply that last term by 4, we're going to get 2 times 4 to the n minus 1 times 4, which gets us 2 times 4 to the n. If you don't see that, this is how that happens. Well, if we have 4 times 4 times 4 times 4 times 4, n minus 1 times, right? We have n minus 1 4s there, and we're multiplying that by another 4. So in total, there are n 4s. So in other words, that's 4 to the nth power. So that's how you can see that. So let's look at that again. We have our original sum. We have 4 times that sum. Now, let's subtract it. Let's subtract 4 times the sum minus our original sum. And if we do that, we can see that we have on the left side of the equal sign 4 s sub n minus s sub n. And on the right side, look what happens. The 8's cancel, 32's cancel, 128's cancel. Everything's going to cancel except for the last one, which is 2 times 4 to the n, and the first one, which was 2. So we have 2 times 4 to the nth power minus 2. If you can't see that, if you don't see how that happened, go back, pause, look, write down questions. So we have 4 times s sub n minus s sub n is equal to 2 times 4 to the n power minus 2. Ooh, that's a mouthful. That's complicated. But we can simplify. 4 minus 1 is just 3, so we have 3 s sub n is equal to 2 times 4 to the n minus 2. If we want to solve for s sub n, we just divide by 3. Do it to both sides. Cancel out. So we have s sub n is equal to 2 times 4 to the nth power minus 2 divided by 3. Test it. Let's see if it works. So if n is 4, that means we're adding together the first 4 terms, 2 plus 8 plus 32 plus 128, which gets us 170. And let's see, that's just adding it forwards. How do we test it? We need to look at our formula. So let's use our formula now. So now we're finding s sub 4. Because it's the first 4 terms. So s sub 4, according to our formula, should be 2 times 4 to the 4th power minus 2, all divided by 3. Let's start simplifying and see what we get. 4 to the 4th power is 256. 2 times 256 is 512, minus 2 is 510, so we have 510 divided by 3, which indeed is 170. So that's it. It worked. So what did we do there? Why did we choose to multiply the sum by 4? Think about that. Go back, look, and then maybe you can look back at your do now from Thursday and see if this video helps you figure out the sum for that particular geometric sequence.